Welcome to this exciting presentation of special right triangles. There are two special right triangles that we have to know about, and here they are. They are a 45-45 90-degree right triangle and a 30-60 90-degree right triangle. They are thusly named because this one has two angles of 45, one of 90. This one has a 30, a 60, and a 90. Because of those very special measurements, we can make some special inferences about those two types of triangles and quickly find out their side lengths. First, let's run through the rigmarole here. So in a 45-45 90 triangle, both legs are congruent, and the length of the hypotenuse is the square root of 2, or radical 2, times the length of a leg. So the hypotenuse equals radical 2 times the leg. What's that look like? Well, here's a triangle. What do we know about it? We know it is a 45-45 90 triangle because it is thusly marked. We also know to define the hypotenuse, you multiply the leg times radical 2. So the leg is 9, so I do 9 times radical 2. Radical 2 can be written as a square root, so that's 9 times 1.414, or 12.728. Take a look at another triangle. And I'm kind of thinking maybe we need to bring in a little bit of help here.
Minions assemble!
Don't you just love the minions? They're awesome. All right, here's what we know. It's a 45-45 90-degree triangle, and to find the hypotenuse, we're going to multiply the leg times radical 2. Well, we already have 2 radical 2, so we're going to do 2 radical 2 times radical 2. And so these two things are both under radical, so we can multiply those two things together and keep them under the radical. So it becomes 2 times radical 4. Well, radical 4 is simply square root of 4, so that means that's 2. So 2 times 2 is 4, so the answer is, what's the hypotenuse? X equals 4. Moving on, another example. We've got ourselves a 45-45 90-degree triangle. We know to find the hypotenuse, we're going to multiply the leg times radical 2. But there's a problem here. We've already been given the hypotenuse, but let's think about it for a second. If to find the hypotenuse, we multiply this side times radical 2. If we divide by radical 2, we can find out what x is. So let's do that. 6 divided by radical 2 is 4.24, so x equals 4.24. Okay, now none of those were in your book, so you're just going to have to kind of go along with me here. So we're going on out of the 30-60-90 triangle theorem. Here's what it looks like. 30-60-90 triangles, the length of the hypotenuse is 2 times the length of the shortest leg. The length of the longer leg is radical 3 times the length of the shortest leg. So the hypotenuse equals 2 times the shortest leg, and the longer leg is radical 3 times the shortest leg. What does this look like? Again, these are not in anywhere in your book. These are just some ones I just pulled out here. So what do we know about this? Well, it is a 30-60-90 triangle. So therefore, to find the hypotenuse, we multiply the shortest side times 2. To find the longer leg, we multiply the shortest leg times radical 3. So this right here is going to be the longer leg. And so once again, just like in the last problem, we did not have a specific thing to go. But if we know that the long side is radical 3 times the short side, then if we divide the long side, if we have that, by radical 3, that'll tell us what the short side is. So we're going to do 5 divided by radical 3. That is about 2.89. So that means the d, the short side, is 2.89. And to find f, the hypotenuse, we just do 2 times that because the hypotenuse is going to be twice as long as the shortest side. So 2.89 times 2 is 5.77. One more example. Again, still not in your book. So here we have, once again, a 30-60-90 triangle. The hypotenuse is equal to the short side times 2, and the long side, the long leg, is the shortest leg times radical 3. Now we're being given the hypotenuse, so once again we're going to divide that by 2 to find out the short side. So 8 divided by 2 is 4. So this is 4, so that means to find y, we're going to multiply that times radical 3. 4 times radical 3 is 4 radical 3, which is approximately equal to 6.93. Back to the notes now, and let's see what we got here. We're going to fill some things in here. This is a 45-45 90 triangle, and we're going to find the hypotenuse here. So here's the hypotenuse. The two sides are 5 radical 6. So I'm going to take the hypotenuse times radical 2 times a leg. The hypotenuse is going to be equal to radical 2 times a leg. So radical 2 times 5 radical 6. So 5 times radical 2 times radical 6. I'm allowed to do that. And so then I can pull them both back underneath the same radical, so it's 5 radical 2 times 6. And I'm going to get rid of this line. I don't like how they did this in the book, so you can cross that out and write it this way. It's 5 radical 12. And so then we've got 5 times, well, the square root of 12 is about 3.46. So the length of the hypotenuse is going to be 5 times 3.46, which is 17.32. We want to apply the 45-45-90 triangle theorem. So we've got here a park, and it's a square park. The playground is 96 feet on each side. And so we want to find out if we put a walkway from one side to the other, how long will that walkway have to be? Well, so I've got a 45-45-90 triangle, so that means that the hypotenuse is going to be equal to radical 2 times one of the legs. So I do that. Now, to find out what it is, I'm going to divide by radical 2. So I got 96 divided by radical 2, so that means the leg equals 67.88, and we want to round this to the nearest foot, so that's going to be about 68 feet. Next up, using the length of one side, we want to find the value of each variable, and we're going to use the 30-60-90 triangle theorem to find the lengths of the legs. So here's what we've got. 30-60-90, we know the hypotenuse is 4 radical 3. So the hypotenuse, 4 radical 3, is equal to 2 times the shorter leg. Well, we don't know what the shorter leg is, so we're going to have to do some division. So it's going to be divide both sides by 2, so 4 radical 3 divided by 2. Since these two things are real numbers, 4 and 2, I can just divide 4 divided by 2, and I get 2, and the radical 3 just comes along. Now we simplify. That's about 3.46. So that's one answer there. So now we want to find what y is. So y is going to be radical 3 times the shorter leg. That's from the 30-60-90 triangle theorem. So we do 2 radical 3 for the shorter leg, multiply that times radical 3. So I've got 2 times radical 3 times radical 3. Radical 3 times radical 3 would make it radical 9. And radical 9 is the square root of 9, which would be 3, so it's 3 times 2, so that's 6. So that means the length of the shorter leg is 3.46, longer leg is 6. Ordinarily, I'd have you do the quick check right now, but I'm just going to leave that go for a minute and come back to it later, so I'll have the answers to that at the end of the video. So we want to apply the 30-60-90 triangle theorem. We've got a rhombus-shaped garden that has a perimeter of 100 feet and a 60-degree angle right here. We want to find the area of the garden to the nearest square foot. Well, here's what we got. Because the rhombus has 4 equal sides, we know each side is 25 because it's 100 feet for the perimeter all the way around. So that means that each side would be 25. So let's fill that in. Now, because a rhombus is also a parallelogram, we can use the area formula, which is 1/2 base times height. So we're going to draw an altitude h and then solve for h. Because what we're going to do is we're going to turn this into a 30-60-90 triangle. So here's our 90-degree angle. I'm not marking it. That's a 60-degree angle, and so that means that has to be a 30-degree angle up there. So the height h is the longest leg of the triangle, so we want to find that height h. We're going to use the properties of a 30-60-90 degree triangle and then apply the area formula. So we're going to take the hypotenuse, and that is equal to 2 times the shorter leg. So the hypotenuse is 25, so 25 equals 2 times the shorter leg, so we've got to do some division. Divide both sides by 2. 25 divided by 2 is 12.5. That means the height is 12.5. So the longer leg is equal to radical 3 times the shorter leg. So I get 12.5 times radical 3. Now, I use the formula for the area of a parallelogram. That is 1/2 base times height. The height's 12.5. The base was radical 3. And so I get 10.83. And to the nearest square foot, you can almost see that it is 11 feet. 11 feet is your last answer. Now, time for you to do the quick check on pages 147 and 148. 147 is pretty easy. 148, the first one's a little bit messed up, and I'll explain that in a second. Bada bing, bada boom, here we go. On the quick check, number 1, find the length of the hypotenuse of a 45-45-90 triangle. It has leg lengths of 5 radical 3. Here's what I got to do. I know that the hypotenuse is going to be the side length times radical 2. So 5 radical 3 times radical 2 leaves me with 5 times radical 3 times 2. That's 5 radical 6, which is approximately 12.25. Got a square garden. Each side is 100 feet long, and we want to build a brick path along a diagonal of the square. So let's get ourselves a square. Each side is 100 feet long, and I'm going to make a path going down the middle right here. And so I want to find out what that is. So this is going to be obviously a hypotenuse of two separate triangles. This is a right angle, so that's 45, that's 45, so I can use 45, 45, 90 properties. So here's what I got. I'm going to multiply to find the hypotenuse, the side times radical 2, and that is 141.42 roughly, which rounds to about 141 feet. Last part. This was really messed up. I didn't realize it until afterwards that this triangle is not marked in your books. The triangle's there, the numbers are not there. So let's do it anyway. It's supposed to be that the hypotenuse is 8. This is a 30-degree angle. This is a 60-degree angle. Anyway, so if the hypotenuse is 8, that means the short side is half of 8. Half of 8 is 4. And then the long side would be the short side times radical 3, that's 4 radical 3. Then down here at the bottom we got a rhombus that has 10-inch sides, 2 of which meet to form the indicated angle. So we do all the work, we figure out, and we find out that a 30-degree angle one would be 50 square inches, a 60-degree angle one would be 50 radical 3 square inches.